In this video, I will show you how to differentiate algebraic fractions or expressions in overall forms, meaning one thing is divided by another thing, by using algebra. As a quick little disclaimer, I'm not going to use the quotient rule for derivatives for this one. This is another topic. My point is to show you how to break it up with algebra. I'm going through all of these two examples. Let's get started with the first one. Since your top happens to be heavier, so all you want to do is just separate numerators by dividing 3x plus 2 by x. So you want to split it up into two fractions. So 3x over x plus 2 over x. So x goes away and you end up getting 3 from the first one plus 2 over x, and we want to bring it x up in order to fit it into power rule for derivatives, and we want to make the power of x negative, so x actually goes with this invisible power of 1, and when we bring it up to top, your power becomes negative. Now let's apply a power rule. So the derivative of 3, the derivative of any constant is just 0, so 3 goes away. Now by multiple constant rule, so we want to keep these two right off the bat first of all, and now let's apply a power rule to x to the negative 1. So as a rule of thumb, you want to bring this power in front as the coefficient in front of your term, and you want to decrease the power by 1, so knock it down by 1, so n minus 1. Now this negative 1 comes out front, so 2 times negative 1, and your new power becomes negative 1 minus 1, which is negative 2. Let's clean it up a little bit. So pull out negative, and we have 2x to the negative 2. Now we want to bring this variable down in the denominator by making the power positive actually. So it's going to be 2 over x squared. So that's your final derivative for this problem. All right. Let's move to the second one. The same idea applies over there. So we want to break up the numerator by dividing through x squared. So it's gonna be negative 1 from the first term. Now negative 9 over x, so x and x, they cancel each other out. So you are left with just 1x on the bottom, and for the last term is going to be 3 over x squared. Now let's bring all of these x's to the top in order to use the power rule afterwards. So it becomes we want to keep this negative 1, so 9x to the negative 1 plus 3x to the negative 2 power. So your derivative dg dx, or just g prime, you could use another prime notation, equals. So we're going to have a look at this expression, the last one. So the derivative of negative 1 is just 0, goes away. Keep negative 1, bring negative 1 in front, and reduce your power by 1. Negative 2 plus 3, negative 2 comes out front, and your new power, negative 3, minus 2 minus 1. All right, let's clean it up. So it becomes 9x to the negative 2 minus 6x to the negative 3 power. And we are going back. We want to turn it into positive power. So 9 over x squared minus 6 over x cubed. And that's your final derivative for this one. As a quick reminder, exponent rules from algebra.